Use the graph of the function f to decide whether each quantity exists. There are two problems in here that do not have the limit in front. Those are basically function notation values where you are given the x value. For example, when you see f of 1, you're simply asked to find the y value paired with the value of x equals 1 on your function. This graph only has a defined point at 1, 4. So that function value is 4 because the function, even though there's two hollow points, this point is defined, its x value is 1, and you're looking for 4. That's the y value paired with 1. Jump down to this third part, f of 4. You go to where x is 4. If you can find it on your graph where it's defined, then you'll have a function value. This particular graph does not have a filled in circle when x is 4, therefore it does not exist. There is no y value that pairs up with the x value of 4. When it comes to limits, you're looking at the approach value, and so for the limit as x approaches 1 of our function, we are looking for a common y value when we approach 1 from the left side and when we approach 1 from the right side. We do not get a match. As we approach 1 from the left side, our y value is approaching 7. When we approach 1 from the right side, our y value is approaching 1. Therefore, that limit does not exist. At the very bottom, the limit as x approaches 4, I've got noted in green. As we approach from the left, the y value is approaching 4. As I approach from the right, my y value is also 4, and so that has a limit value of 4. The graph of the function x plus 1 is shown in the figure, and that's this black solid line. Find the largest delta such that if the absolute value of x minus 2 is positive and between 0 and our delta value, then our function and its distance from 3 is less than 0.4. So this absolute value, that's the distance between our function and the value of 3. If you look at our y-axis, our function value of 3, if we're allowed to be 0.4 units away, that means we can either be down to 2.6 or up to 3.4. In our function, we have x plus 1. If you're looking for a y value, then you subtract 1. So 3.4 minus 1 is 2.4. If we trace this top red dotted line to the function, it'll carry an x value of 2.4. 2.6 minus 1, solving for x, is 1.6. Our x value of 2 is 0.4 units away from either 1.6 or 2.4. That's our value of delta. Probably the easiest way to show that is to replace f of x with your function value x plus 1, subtract 3, and you've recreated your original compound inequality. X minus 2 less than delta, x minus 2 less than 0.4. That's your delta value. So delta is the gap between your x value and the discrepancy created by your epsilon.